So in this lesson, we're going to take a look at how you calculate the derivatives of the sine and the cosine function. And eventually, we're going to use these derivatives to solve the type of problems that we've been solving throughout the calculus portion of this course. So if you're interested in the derivation of the functions that are the derivatives of sine and cosine functions, they are derived in the learning guides. We are just going to sort of quote the results right here. So if you have the function y equals sine x, the derivative, y primed, is the cos x function. And if you start with a cos x function, the derivative is negative sine function. Okay? So those are the two derivative rules that we're going to be using in this lesson. Okay? And there they are at the top again. So for most of the time, you're going to have to combine these two derivative rules with the derivative rules that you've already learned up to this point in the course. So let's just do a quick example here. Our first one here is y equals sine of 2x. So in this case, we are going to have to use the chain rule. We have got a function that is y equals sine of some other function of x, g at x. So how can we apply the chain rule to take our derivative here? Well, our outermost function is the sine function, so we want to do first the derivative of sine. Now we know what derivative of sine is, we just did that. Derivative of sine is going to be the cosine function. So we've done the derivative of the outside function. Our inner function is the 2x, so we're going to keep that 2x the same. So our first term here is going to be cosine of 2x. Chain rule, we multiply by the derivative of that inner function. Our inner function is just 2x, so our derivative is going to be 2. So we could rewrite this if we wanted to as 2 cos 2x. Next example here, we've got y equals cos squared x. Okay. Now, the squared here is on the cosine function here. So when you see the squared on the cosine function, you want to interpret this as cosine of x, the entire thing squared. Okay. So that entire cosine function is being squared. This is not the same as if you see cosine of x squared. So if you see cosine x squared, what this means is that it's just the x that has been squared, and then you're taking the cosine of it. So this is important. It's an important distinction when you're using the chain rule, because it changes what is your outer function and what is your inner function. So we have cosine of x all squared. Well, let's figure out what our derivative is going to be. So how would you find your derivative here? Chain rule. Derivative of the outer function. Outer function is something squared, so we're going to bring down that 2. We're going to keep our inner function, cos x, exactly the same. And then we're going to multiply by the derivative of that inner function. So what is the derivative of cos x? Well, we had those up at the top of the page. Derivative of cosine x is negative sine x. So just cleaning it up a bit, we get negative 2 cos x sine x. All right, slightly trickier here. Y equals sine of 4x squared times cosine of 3x. So what derivative rule are we going to have to use here, in addition to our sine and cosine derivative rules? Emily? Product rule, and both of our trig functions are also composite functions, so we're also going to be using the chain rule in here. So if we're using product rule, we first want the derivative of that first function. Our first function is sine of 4x squared. So our derivative is going to be, let's see, our outer function, derivative of sine is cos. So we want cos 4x squared times the derivative of the inner function. That inner function there is 4x squared. So our derivative is going to be 8x. This whole thing gets multiplied by cos 3x. Okay, that's our product rule. We've got u, v, so this is u primed times v. To this, we are going to have to add u times v primed. So we need our original u function, sine 4x squared. And the derivative of v, well, let's see, what's the derivative of cosine of 3x? Outer function is cosine. So derivative of cosine is negative sine. Keep the inner function the same. And then multiply by the derivative of the inner function. So inner function is 3x. So we multiply this by 3. And then we can just sort of rearrange it, putting all the coefficients up at the front. So we'll have 8x cos 4x squared cos 3x minus 3 sine 4x squared sine 3x. Now, as always, when we're doing a big long derivative like this, we always ask ourselves, is there something that we can factor out of these terms? And when you're doing trig derivatives like this, often you can't factor something out because, like notice in the first term we've got cos 4x squared, in the second one we've got sine 4x squared. In the first one we've got cos 3x, and the second one we've got sine 3x. So because those the trig functions kind of flip-flop as we do the derivatives, you can't always factor them. Last example here, we will combine our trig derivatives with one of the derivatives that we did in the last unit here. We want to find the derivative of ln cos x squared 3x. So to do this one, I think it's going to be helpful to rewrite the original function. So I see that cos squared, so I'm going to rewrite that cos squared as cos 3x all squared. Okay. Just to clarify it a little bit. Now, there's another step I can do to rewrite this involving the ln. What do we think, Nicole? That would actually be taking our derivative. Even before we take our derivative, what can we do with that exponent of 2? Right? Yeah, we can use that power law and we can bring it down out front. So we can rewrite, again, this is still our y. We haven't taken our derivative yet. So our original function, write it as 2 ln of cos 3x. How does that help us? Well, it just means that we have one less function that is sort of nested inside there. Okay? So instead of a function something x squared, we just have a constant 2 out front. Now we can go ahead and take our derivative. So that 2 is just going to stay out front as a constant. And now we want to do the derivative of, well, working our way out towards the inside. Our outermost function is ln. So the derivative of ln is going to be 1 over cos 3x. Okay? Just as Nicole said, ln is base e. So we don't have that factor ln of the base coming in. That only happens when we have bases other than e. Now we have to apply chain rule. So we've done derivative of ln. The next function as we go in is our cosine function. So we want the derivative of cos 3x. Well, the derivative of cos is negative sine 3x times the derivative of the innermost function, which is 3. So putting this all together, we get negative 6 sine 3x over cos 3x. Now, in this case, this actually does simplify a little bit. If we've got cos of something sine of something divided by cos of the same thing. How can we simplify that a little bit? This is a trig identity here, Alana. Yeah, this becomes tan. So this could actually be written as negative 6 tan 3x. Okay. Now, it is not necessary that you simplify expressions like this using trig identities. You will have a trig identity sheet. I think there's one attached to the back of your guide. We're going to use those trig identities mostly when we have to solve equations. Okay? But if it's just you've got an expression, simplifying it using identities is completely optional. Okay?